Now I will tell you about the application of dimensional analysis. By analyzing dimensions, you can find out a dimension of an unknown thing on at unknown constant or at unknown values using this dimensional analysis. So I give you one example. Suppose the equation is given that u equal to half kx square. U equal to half kx square. So the equation is given u equal to half kx square. Here u is potential energy. So the dimension of u is, the dimension of potential energy, m L square t to the power minus 2. Clear? So from this equation, the dimension of k will be the dimension of u divided by the dimension of x square. Clear? So dimension of k, from this equation you have got that the dimension of k equal to dimension of u divided by dimension of x square. Clear? So you can write the values here. The dimension of u is m L square t to the power minus 2. M L square t to the power minus 2 divided by the dimension of x is you all know distance. So the dimension of x is L. So x square is L square. So what you have got, m L square t to the power minus 2 divided by L square. So it will be m t to the power minus 2. M t to the power equal to, this equals to m t to the power minus 2. Clear? So dimension of k is a force constant. The dimension of k is m t to the power minus 2. Clear? Next I will give you some examples. From that you will pause the video and from yourself try first time. Try to find out the dimensions. I am giving you the equations. Try to find out the dimensions of unknown variables. Like here I am giving an equation p plus a by v square into v minus v. Clear? That equal to RT. Van der Waals gas equation. P plus a by v square into v minus v equal to RT. From here, find out the dimensions of A and B. Try it. You all know that P is pressure, V is volume, R is universal gas constant, and T is here temperature. Clear? As I have taught you earlier that P is added with A by V square, so the dimensions of P must be equal to dimensions of A by V square according to the principles of homogeneity. So you can write here the dimension of P is equal to the dimension of A by B square. Okay. You all know the dimension of P is mL inverse T to the power minus 2. How I can got this? You all know pressure is force per unit area. The dimension of force is mL T to the power minus 2, and per unit area, dimension of area is L square, so it is mL T to the power minus 2 divided by L square. So the dimension of P is mL inverse T to the power minus 2. Have you got this? mL inverse, mL inverse T to the power minus 2, that is T to the power minus 2, mL inverse T to the power minus 2. Okay. So the dimension of A will be dimension of A equal to V square will be multiplied with P. Clear? So mL inverse T to the power minus 2 into the dimension of V square. V is volume. You all know volume is L cube. The dimension of volume is L cube. So V square is L to the power 6. So you will multiply mL inverse T to the power minus 2 into L to the power 6. So it will come L to the power 6 into L to the power minus 1, that is L to the power 5. So mL to the power 5 T to the power minus 2. You all have got this. M L to the power 5 T to the power minus 2. Okay. Now you have find out the dimension of A. Now try to find out the dimension of volume. Dimension of B. Here you can easily see that V minus B is done. So the dimension of B must be equal to dimension of volume. Clear? So the dimension of B is the dimension of volume, that is L cube. Clear? So the dimension of B is L cube. Okay. So you have got this. You can even, I have told you earlier that you can even find out some equations from dimensions. How it is possible? I am giving you one example. Say T is the dimension of time period. Okay? So T is in the equation. I am writing small t. Small t is time period. Yeah, small t for time period. Okay. Next, small l for effective length, maybe of a pendulum, effective length of a pendulum. And you all know small g is for gravitational acceleration, that is acceleration. The dimension of acceleration is 8 t to the power minus 2. Gravitational acceleration. Gravitational acceleration. Clear? Now find out the relation in between T, L and G. So say, let's write T equal to I assume a relation that T equal to K is a constant. It may present or may not. It is a dimensionless constant. Remember this. K is here a dimensionless constant. So T equal to K into L to the power A into G to the power B. Clear? So I have written the equation as an assumption T equal to K into K is a dimensionless constant, L to the power A, G to the power B. So let's find out A and B. If we can find out the values of A and B, then we have got the formula. Okay? We have got the formula. We will put the values of A and B in this formula after finding. So that we will relate the dimension of left side with the dimensions of right side. Clear? So here the dimension of left side is capital T, that is time. So dimension of left side is capital T equal to L to the power A. I am not using third bracket from now for time issues. L to the power A into G is gravitational acceleration, so its dimension is 8 t to the power minus 8 t to the power minus 2. L, it is third bracket. Clear? You have to write it in third bracket. I am giving first bracket for my easement. 8 t to the power minus 2. Clear? L to the power A into L t to the power minus 2. So if we relate, we can see that the power of L is at left side equal to L to the power I have to write something. Wait. G to the power B. So L t to the power minus 2 to the power B. So the power of L is L to the power A plus B. L to the power A plus B. So I have to write here. So it will be L to the power A plus B, A plus B into t to the power minus 2b, t to the power minus 2b. Clear? So in left side there is the power of L is 0. So relating left side and right side, we can find out that a plus b must be 0. Clear? Why a plus b 0? Because left side L has no power, that is L has 0, L to the power 0, the power of L is 0, and in right side the power of L is a plus b. As both will be equal, so 0 equal to a plus b, and similarly 1 equal to minus 2b. So from there we can got that minus 2b equal to 1, so the values of b will be minus half. Clear? So the values of b will be minus half, and from I have told you earlier that a plus b equal to 0, so you put the value of b half here, so a plus half equal to 0, so the values of a will be minus half. Clear? Because a plus b 0, a plus half is equal to 0, so a equal to minus half. Clear? So a, we have got that a value of a is minus half, and value of a is minus half, and value of a is half, and value of b is minus half. Clear? So we have got this. I am going for a new page. Value of a is half, and value of b is minus half. Clear? So we put these values on the equation, and we find out it that t equal to L to the power k into k is a codimensionless constant, so k into L to the power a, that is L to the power half, and g to the power minus half. Okay, so we can write k into half is the root, so k into L by g. So time period equal to k into root over of L by g. So we have got the equation. Clear? We have got the equation from this. Okay, let's go for new page. Another question may be asked in this dimension chapter, that suppose the dimension of force is F. What has been told that dimension of force is F, dimension of velocity is V, and dimension of frequency is N. Clear? F, V and N, and they are by assuming this, find out the dimension of mass. So the question is, dimension of force is F, dimension of velocity is V, dimension of frequency is N, and from these find out the dimension of mass. From this find out the dimension of mass. Clear? So what we will do, we will find a equation first. We will assume a equation first, that mass equal to, say mass equal to F to the power A, F to the power A, V to the power B into C to the power I have already has assumed C, so C to the power P. Clear? So M equal to F to the power A, V to the power B, C to the power P. Sorry, N. It was N. The frequency was N. V to the power B, n to the power c. Clear? Now I have to find out the values of a, b and c. How I will do this? I will relate the same thing, the left side and the right side, the dimensions of the left side with the dimensions of right side. So I will write here the dimensions of force to the power a. I am writing this, that is, I am using first bracket m l t to the power -2 to the power a. So to the power a. Next, b to the power b, the dimension of velocity is lt inverse. To the power b. Next, frequency. The dimension of frequency we all know, t to the power -1. So it is t to the power -1. Okay. By doing this, we found out m to the power. We find out that m to the power a. Clear? M to the power a. M to the power a into L to the power a plus b. Clear? L to the power a plus b. So it will be, I am giving first bracket for your is a plus b into t to the power minus 2a minus b sorry, it was c. So minus 2a minus b minus c. I have forgot the c here. Okay, I am writing here it. I will add it later. So here it will be t to the power minus 2a minus b minus c. Clear? T to the power -1 to the power -6, because the frequency to the power c chilo. So it is to the power c. To the power c. Okay, we have done this. So it is m to the power a to the power a plus b, t to the power -2a minus b minus c. So from equalizing left side with right side, we can got three equations here, and there are three unknowns a, b and c. From this we can got the values of a, b, c. How it is? The power of m at left side is 1, the power of m at right side is a. So we can easily find out that a equal to 1. So we can find out that a equal to 1. Next, a plus b, the power of L at right side is a plus b, and the power of L at left side is 0. So a plus b equal to 0. So a plus b equal to 0. Next, power of t at right side minus 2a minus b minus c, power of t at left side is none, that is 0. Clear? So it will be minus 2a minus b minus c equal to 0. By solving three equations, we can get b equal to minus 1. Putting these values in minus 2a minus b minus c, that is minus 2 plus 1, that is minus 1, minus c equal to 0. So c is also minus 1. So b equal to minus 1, c equal to minus 1. Have you got this? So b equal to minus 1, c equal to minus 1. So from this equation, b equal to minus 1 and c equal to again minus 1. Okay. So we got the values of a, b and c. So we got the dimension of mass here. What will be the dimension of mass? M equal to, I am writing f to the power 1, that is f. So capital F, v to the power minus 1, clear, and c to the power minus 1. So f by v into n, clear. So mass dimension is f v to the power minus 1 n to the power minus 1. That is the dimension of mass in this new measurement technique. Clear? This is all about the units and dimensions of the chapter. I will come back later about new chapters. So all the best for all of you. Thank you for watching.